The space community has long recognized the superiority of SpaceX's Falcon Heavy rocket over the United Launch Alliance's rockets in terms of cost and capacity. However, because of its prestigious backing as a joint venture between aerospace giants Lockheed Martin and Boeing, ULA continued to dominate military contracts, resulting in significant national budget inefficiencies. But that dominance may finally be coming to an end. As ULA's rockets become increasingly outdated in a fast-paced aerospace landscape, and as SpaceX rapidly advances with cutting-edge rockets like the Falcon Heavy, the Pentagon has been forced to seriously reconsider the economic advantages of commercial launch providers. That shift in thinking led to a recent major Space Force decision, one that could reshape the future of national security space missions. Find out everything in today's episode of TechMap. The Falcon Heavy is a heavy-lift rocket developed by SpaceX, a private aerospace company. When it was first launched on February 6, 2018, it became the most powerful rocket in operation, second only to NASA's historic Saturn V, which carried astronauts to the Moon. That inaugural flight accomplished nearly all its key goals, including the headline-grabbing stunt of sending CEO Elon Musk's personal Tesla Roadster into orbit, piloted by a mannequin nicknamed Starman. Despite its impressive specs, capable of carrying up to 63.8 tons to low Earth orbit (LEO), demand for Falcon Heavy has remained relatively low compared to the more frequently used Falcon 9. In 2024, for instance, only 2 Falcon Heavy missions were launched out of 138 total SpaceX missions. This is largely because most commercial and satellite payloads don't require such a powerful rocket, making the Falcon 9 a more cost-effective choice for routine missions. However, that doesn't mean the Falcon Heavy has been sidelined. Quite the opposite. It's still a strong revenue driver for SpaceX through high-value government contracts. The company has strategically positioned Falcon Heavy as a cost-efficient and reliable competitor to United Launch Alliance, ULA, for military payloads. In fact, back in 2018, it won its first major classified military contract by underbidding ULA's Delta IV Heavy as part of the Evolved Expendable Launch Vehicle program. Priced at $130 million per launch, Falcon Heavy presented a compelling alternative to ULA's more expensive offerings. In the National Security Space Launch (NSSL) Phase 2 competition in 2020, SpaceX was awarded 40% of the total contract missions, several of which were assigned to Falcon Heavy. That share increased to an impressive 60% in Phase 3, marking a significant increase in upcoming launches using Falcon Heavy. For instance, this year's awards granted SpaceX 7 missions worth a total of $845.8 million, including 4 Falcon Heavy launches. In contrast, ULA received just 2 missions worth $427.6 million. That's an average of $120.8 million per SpaceX mission versus $213.8 million for ULA, reinforcing SpaceX's competitive pricing. These latest contract wins underscore a broader shift in military space launch dominance from ULA to SpaceX, a shift that, to many, feels inevitable. For years, the Falcon family has been known for its affordability and readiness. To put things in perspective, a Falcon 9 commercial launch costs just $69.75 million, while a reusable Falcon Heavy launch is priced at $97 million. Compare that to ULA's retired Delta IV Heavy at $350 million, and their newer Vulcan Centaur rocket, which starts at $110 million. SpaceX's edge comes from reusability. Its boosters are routinely recovered and reused, drastically cutting costs. In today's global climate, where China's space capabilities are expanding quickly, the U.S. military needs cost-efficient, dependable options. And Falcon rockets meet that need. Despite being more affordable, Falcon Heavy offers an impressive payload capacity, capable of lifting up to 63,800 kilograms to LEO. It's second only to NASA's SLS in power, making it ideal for heavy and interplanetary missions. By contrast, ULA's Vulcan Centaur, which replaces the Atlas V and Delta IV, is designed to be affordable and reliable, but isn't reusable. With 6 solid rocket boosters, it can carry up to 27,200 kilograms to LEO, comparable to Delta IV Heavy, but cheaper. Another factor in SpaceX's favor is readiness. The Falcon 9 was certified for U.S. military missions back in May 2015, following an intense 2-year evaluation. Vulcan, meanwhile, only recently received its military launch certification, years later than planned. In fact, ULA was hit with financial penalties last May due to delays in 2 military satellite launches. On top of that, ULA's West Coast launch pad for Vulcan still isn't operational, meaning the company can't be assigned West Coast missions until it's completed and certified. Because of this, SpaceX was awarded the NROL 96 and NROL 157 missions by default. Both missions require launches into lower energy orbits from the Western Range at Vandenberg Space Force Base. That said, the Pentagon isn't putting all its eggs in one basket. While SpaceX may currently lead in cost and capability, the Department of Defense remains committed to a diversified supplier base, bringing in other players like Blue Origin and Rocket Lab to ensure continued access to space. Clearly, SpaceX becoming the top launch supplier to the Pentagon recently could further exacerbate significant financial hurdles that ULA is facing. For over a decade, United Launch Alliance had an absolute monopoly. If the Pentagon wanted to send a spy satellite to space, the Boeing Company and Lockheed Martin Corporation venture was its only choice. Unfortunately, everything has changed now. ULA's revenue has been impacted by delays in customer missions and the loss of market share to SpaceX, leading to a decline in revenue and making it difficult to meet profit goals. Additionally, budget overruns, partly due to the transition to the Vulcan rocket and maintaining legacy systems, have strained ULA's financial situation. SpaceX's success in securing a large portion of military contracts reduces ULA's opportunities for revenue growth, directly affecting its financial stability. The increased competition from SpaceX's cost-effective and reliable launch services raises the bar for competitors, forcing ULA to either match these standards or risk losing more contracts. Furthermore, ULA is struggling with a significant exodus of engineers to competitors like SpaceX and Blue Origin, complicating its ability to maintain operational efficiency and innovate quickly. The delays in certifying the Vulcan rocket have also hindered ULA's ability to secure lucrative Pentagon contracts, impacting its launch cadence and revenue projections. These challenges have led to discussions about a potential sale or restructuring of ULA, with Blue Origin reportedly considering an acquisition, which could significantly alter the competitive landscape. To be honest, the merger between Blue Origin and ULA would bring strategic advantages, such as synergies in technology and infrastructure, as ULA's Vulcan Centaur rocket already uses Blue Origin's BE-4 engines, which would streamline operations and reduce supply chain complexities. Additionally, ULA's established launch facilities and long-term Department of Defense (DoD) and NASA contracts would bolster Blue Origin's capabilities and create a powerful entity capable of competing more aggressively with SpaceX for military and commercial launches. However, challenges would arise from integrating the work culture of 2 separate companies, and the financial risks of acquiring ULA would require significant investment, especially as both companies are still developing next-generation rockets. The future role of ULA CEO Tory Bruno would also be uncertain, and maintaining strong leadership would be crucial for success. 3 National Security Space Launch Phase. 3-lane. 2 contracts were awarded on April 4th by Space Systems Command. These firm fixed-price, indefinite delivery requirements contracts were awarded to SpaceX, United Launch Services, and Blue Origin to provide critical space support to meet national security objectives. Anticipated values for these contracts are $5,923,580,297 for SpaceX, $5,366,439,406 for United Launch Services, and $2,386,234,812 for Blue Origin. A robust and resilient space launch architecture is the foundation of both our economic prosperity and our national security, said U.S. Space Force Chief of Space Operations General Chance Saltzman. National security space launch isn't just a program. It's a strategic necessity that delivers the critical space capabilities our warfighters depend on to fight and win. Major General Stephen Purdy, Acting Assistant Secretary of the Air Force for Space Acquisition and Integration, highlighted the critical role of space dominance in national security. America leads the world in space launch, and through these NSSL Phase 3 Lane 2 contracts, we will ensure continued access to this vital domain, he stated. These awards bolster our ability to launch critical defense satellites, while strengthening our industrial base and enhancing operational readiness. The overall NSSL Phase 3 mission manifest has almost doubled compared to Phase 2, with an anticipated 84 missions being awarded from fiscal year 25 through fiscal year 29. The increased manifest enabled the program to use the dual-lane acquisition strategy, creating the most cost- and time-efficient solutions for NSSL launch. Phase 3 has been able to split the manifest into the commercial-like Lane 1 missions, approximately 30 missions, and Lane 2, approximately 54 missions, which will secure assured access and the highest reliability for our most demanding, least risk-tolerant payloads. Today's award culminates nearly 3 years of government and industry partnership to increase launch resiliency and capacity, explained Brigadier General Kristen Panzenhagen, Program Executive Officer for Assured Access to Space. The result is assured access to space for our national security missions, which increases the military's readiness. SpaceX, as the Requirement 1 provider, is anticipated to be awarded 28 missions, or about 60%, and ULA, as the Requirement 2 provider, is anticipated to be awarded 19 missions, or about 40% of the Phase 3 Lane 2 missions from fiscal year 25 through fiscal year 29. Blue Origin, as the Requirement 3 provider, is projected to be awarded 7 Phase 3 Lane 2 missions starting in Order Year 2. Mission awards in fiscal years 25 through 29 are projected to have a nominal 2-year integration, resulting in launches from fiscal year 27 through fiscal year 32. SSC, in partnership with the NRO, will conduct the Phase 3 Lane 2 Mission Assignment Board to assign the fiscal year 25 Order Year 1 missions, and will make those announcements separately following completion of that process, and then in October of each subsequent order year. After 2 failed landing attempts in 2024 and 2025, respectively, Intuitive Machines decided to come back more robustly. It has recently selected SpaceX's Falcon 9 rocket to launch its 4th lunar delivery mission, aka IM-4, from Florida, scheduled for 2027. The IM-4 mission is expected to include the launch of 2 lunar data relay satellites intended to support NASA's Near Space Network Services, NSNS, contract. Lunar surface delivery and data relay satellites are central to our strategy to commercialize the Moon. In addition to the contracted NSNS service, the satellites are capable of hosting additional payloads and science sensors to serve commercial industry and other government customers, said Intuitive Machines CEO Steve Altemus. The 2 satellites aboard IM-4 are the 2nd and 3rd planned for deployment as part of Intuitive Machines' 5-satellite lunar communications constellation. The company previously announced that the first of these satellites would launch with its IM-3 mission, introducing a pay-by-the-minute communications model to serve lunar surface missions. The final 2 satellites are expected to follow in subsequent missions, completing the network to fully support both NASA's Artemis program and broader commercial lunar operations. We plan to deploy the first of 5 lunar data relay satellites on our 3rd mission, which will introduce our pay-by-the-minute service. The 2 additional satellites on our 4th mission are intended to scale that service, followed by 2 additional deployments to complete the constellation and fully support NASA and commercial lunar operations, Steve Altemus added. Also, IM-4 is set to carry 6 NASA Commercial Lunar Payload Services Initiative payloads, including a European Space Agency-led drill suite designed to search for water at the lunar South Pole. NASA selected Intuitive Machines, along with Astrobotic and Orbit Beyond, back in May 2019 to deliver science experiments and technology demonstrations to the Moon to service the space agency's Artemis program. NASA picked these 3 private companies as part of its Commercial Lunar Payload Services Initiative, aka CLPS. This is an Intuitive Machines' first collaboration with Elon Musk's SpaceX. The 2 have partnered on every lunar mission from IM-1 through IM-4. The IM-1 mission launched the first Nova-C lander, named Odysseus, aboard a Falcon 9 from Kennedy Space Center on February 15, 2024. It was designed to land autonomously and deliver payloads for NASA and commercial clients. Though the launch was smooth, Odysseus tipped over on landing. Had it succeeded, Intuitive Machines would have been the first private company, and the first U.S. spacecraft in over 50 years to achieve a soft moon landing. Undeterred, the company launched its second lander, Athena, in February 2025. This lander was intended to spend about a week on the Moon, searching for water ice beneath the surface. Unfortunately, it also fell over upon landing, this time inside a crater, rather than on the intended mountain site. The IM-3 mission, still under construction, will also fly on a Falcon 9. However, unlike the first 2 missions, IM-3 isn't tied to NASA's CLPS program. Instead, the mission has an open manifest for commercial and civil customers. Company spokesman Josh Marshall said, "Why does Intuitive Machines keep choosing SpaceX? It's pretty straightforward. Of the 6 CLPS awards made by NASA to date, all are launching on SpaceX Falcon 9 or Falcon Heavy vehicles, other than Astrobotic's first Peregrine lander, which was launched on a United Launch Alliance (ULA) Vulcan rocket on January 8, 2024. The Falcon rocket's performance stands out when compared to other launch vehicles due to its cost-effectiveness, payload capacity, reliability, and flexibility. For example, the Falcon 9 offers competitive pricing, with an estimated cost of approximately $69.75 million per launch. Even its Super Heavy version, Falcon Heavy, costs under $100 million. This makes them more cost-effective than the ULA's rockets, which are notorious for exorbitant price due to not reusability. Falcon 9 offers a payload capacity of up to 22.8 tons to low Earth orbit, while Falcon Heavy can carry 63.8 tons, much more significant than ULA's new flagship Vulcan Centaur, 27.2 tons, and Blue Origin's New Glenn, 45 tons. The Falcon 9's reliability is also unmatched, with a proven track record of over 400 successful launches. This is a record that no other rocket has achieved, contributing to the company's leading position in sending Earth payloads into orbit. This reliability is critical for NASA's CLPS missions, which aim to deliver scientific instruments and technology demonstration packages to the Moon. In contrast, both Vulcan and New Glenn are years behind. The new Vulcan has just been certified for national security space launch missions after years of development and a financial penalty from the U.S. Air Force for the long delay. Blue Origin's New Glenn has not been operational yet. Last, but certainly not least, in terms of technical capability, the Falcon 9 can deploy lunar landers on trajectories that minimize propulsion requirements for onboard systems, allowing landers to carry more payload mass to the Moon. For example, Firefly Aerospace selected Falcon 9 for its Blue Ghost mission because it enabled the delivery of over 330 pounds of payload to the lunar surface while optimizing fuel usage. SpaceX's Falcon rockets are also highly estimated in terms of flexibility across CLPS missions. It has been selected by multiple CLPS providers, including Firefly Aerospace, Intuitive Machines, and Astrobotic, demonstrating its adaptability to various mission profiles and payload requirements. Overall, the Falcon 9's proven reliability, cost efficiency, payload capacity, and high flexibility make it the preferred choice for CLPS missions, supporting NASA's Artemis program objectives by delivering critical scientific and technological payloads to the Moon. While ULA's Vulcan Centaur also plays a role in the CLPS program, the Falcon 9 remains the dominant choice due to its established capabilities and operational advantages. However, the Falcon rocket line won't be around forever. SpaceX is already testing its next-generation launch system. Starship, which the company has confirmed, will eventually replace both the Falcon 9 and Falcon Heavy. SpaceX President Gwynne Shotwell put it clearly last year. "Starship obsoletes Falcon 9 and the Dragon capsule," she said. "Now we are not shutting down Dragon, and we are not shutting down Falcon. We'll be flying that for 6 to 8 more years, but ultimately, people are going to want to fly on Starship. It's bigger, it's more comfortable, it will be less expensive, and we will have flown it so many more times." Designed to be fully reusable, Starship is expected to dramatically reduce launch costs while increasing payload capacity far beyond the limits of any current vehicle. Unlike Falcon 9 or Falcon Heavy, which discard parts of the rocket during flight, Starship is built to return both its booster and upper stage for reuse. This shift means SpaceX could bring the cost per launch down to as little as $10 million once the system reaches operational maturity, a massive leap compared to the current roughly $70 million cost for a Falcon 9 launch. But cost isn't the only factor. Starship will also be a game-changer in terms of capacity. While Falcon Heavy can lift 63.8 tons to low Earth orbit in expendable mode, future versions of Starship are expected to carry much more. Starship version 2 is projected to haul over 100 tons to orbit, and the upcoming Starship Block 3 may exceed 200 tons, a capacity no launch system in history has achieved. For comparison, even NASA's Powerful Space Launch System, SLS, maxes out at around 130 tons to LEO. With such capabilities, Starship could eventually account for over 99% of Earth's payloads to orbit, assuming it achieves a high launch cadence. That level of lift capacity isn't just about launching satellites. It's a key requirement for Elon Musk's long-term vision of making humanity multi-planetary. According to Musk, building a self-sustaining city on Mars would require transporting at least 1 million tons of cargo, a goal that would cost over $1,000 trillion using today's technology, a number far beyond the current U.S. GDP of $29 trillion. However, he believes Starship can bring that cost down by a factor of 1,000, making the total Mars colonization project cost about $1 trillion. Spread over 40 years, that breaks down to around $25 billion annually, which Musk argues is a manageable figure that wouldn't materially affect people's standard of living on Earth. That's why, although Falcon and Starship are both classified as heavy-lift vehicles, Starship is in a league of its own. It's not just a rocket, it's a full-fledged transportation system, featuring a reusable booster and a multi-purpose spacecraft capable of carrying both cargo and crew. While Falcon 9 and Falcon Heavy have been highly effective for deploying satellites, resupplying the International Space Station, and even sending payloads toward the Moon, Starship is built for far more ambitious missions. It's designed to ferry people and supplies not only to low Earth orbit, but also to the Moon, Mars, and back, playing a critical role in the future of interplanetary travel. Its potential doesn't stop there. Starship is also suitable for suborbital point-to-point missions on Earth, opening up possibilities for ultra-fast global travel in the future. The concept behind these Earth-to-Earth flights involves launching Starship to suborbital altitudes, allowing it to coast above the atmosphere before descending rapidly to its destination. Though still in development, this idea carries far-reaching implications. For businesses, it could mean same-day global shipping. For travelers, it could turn a 15-hour international flight into a 30-minute hop. For governments, it introduces new possibilities for rapid response capabilities. This potential hasn't gone unnoticed by the military. As early as 2020, the U.S. Transportation Command, USTRANSCOM, began exploring how Starship might be used to move critical cargo, or even personnel, anywhere in the world at unprecedented speed. Think about moving the equivalent of a C-17 payload anywhere on the globe in less than an hour, said General Stephen Lyons, then commander of USTRANSCOM, during an October 2020 briefing. Think about that speed associated with the movement of cargo and people. There's a lot of potential here, and I'm really excited about the team that's working with SpaceX on an opportunity, even perhaps as early as 2021, to conduct a proof of principle. While such missions are still in their early stages, the very idea of leveraging Starship for terrestrial transportation illustrates just how versatile and ambitious SpaceX's vision truly is. Whether for civilian, commercial, or defense purposes, Starship could one day redefine how we move across the planet, just as much as how we reach for the stars. NASA and Russia's space agency, Roscosmos, have officially extended their seat barter agreement for missions to the International Space Station until 2027. This collaboration will now also encompass longer duration missions aboard Russia's Soyuz spacecraft. NASA recently announced that astronaut Chris Williams will fly to the ISS on the Russian Soyuz MS-28 spacecraft in November, along with 2 Russian cosmonauts. Another NASA astronaut, Johnny Kim, is already scheduled to go to the station on April 8th with the Soyuz MS-27 crew. These assignments confirm that the seat swap deal between the 2 countries has been extended. This agreement is important because it ensures that there's always at least 1 American and 1 Russian on the space station, even if either country's spacecraft has technical problems or delays. One change in the new deal is that Soyuz missions, starting with MS-27, will now last about 8 months instead of the usual 6. Because of this, Russia will launch fewer Soyuz missions over the next 2 years, 3 instead of 4. NASA, on the other hand, continues to send its astronauts on commercial crew missions roughly every 6 months, depending on other space activities. It's still unclear if Russian cosmonauts will fly on Boeing's Starliner spacecraft, which is another part of NASA's commercial program. Russia tends to be cautious about new and unproven vehicles. For instance, they didn't start flying on SpaceX's Crew Dragon until 2022. So far, there's no confirmation that Starliner will be included in the seat swap. NASA also hasn't officially set a date for Starliner's first long-term mission to the ISS, Starliner 1. The launch has been delayed several times due to technical issues. One of the astronauts originally assigned to that mission, Mike Finke, has now been moved to a different flight on Crew Dragon, which is scheduled for as early as July. To date, the reason behind longer future Soyuz missions remains uncertain. What's clear, though, is that this extended arrangement provides cosmonauts with more opportunities to engage with advanced spacecraft technology and gain first-hand experience aboard Crew Dragon, all while ensuring continued operations on the ISS. In contrast to the tight quarters of the Soyuz, Crew Dragon's modern and roomy interior provides cosmonauts with a distinct experience. A key difference lies in crew capacity. Soyuz can accommodate 3 people. Meanwhile, Crew Dragon is built to carry up to 7 astronauts, though NASA typically limits crews to 4 under the Commercial Crew Program. Even when SpaceX modified seat angles to address landing G-force concerns, lowering the number of usable seats to 4, Dragon still offers greater capacity than Soyuz. Measuring roughly 8.1 meters tall and 4 meters in diameter, with both capsule and trunk components, it's slightly larger than Soyuz. Its crew module draws inspiration from Apollo-era command modules, while the trunk houses solar panels, radiators for heat management, cargo space, and stabilizing fins for emergency scenarios. Dutch ESA astronaut André Kuipers criticized the Russian Soyuz, stating, "It's much too small and tight." NASA astronaut Doug Wheelock, who has flown both the Space Shuttle Discovery and Soyuz, echoed that sentiment about the Russian capsule. "It's incredibly bumpy and hot and cramped," adding, "It's kind of like going over Niagara Falls in a barrel, but the barrel is on fire." Beyond that, Crew Dragon offers greater convenience. SpaceX engineer John Federspiel said the goal was to make Dragon feel like a 21st century spaceship. He elaborated, "Probably one of the biggest features of Dragon are the touchscreens on the inside. We designed them not just to be very functional, but with a user experience in mind." Older spacecraft resembled airplane cockpits, packed with switches, dials, lights, and analog instruments. Commands were input via a mechanical keyboard, and flight relied heavily on a manual control stick. Crew Dragon reinvented that paradigm, replacing traditional controls with 3 large touchscreens in front of 4 side-by-side seats. These screens offer access to as many as 10 different displays, allowing astronauts to monitor systems like guidance, environmental control, and electrical power. Doug Hurley, commander of the first crewed SpaceX mission in May 2020, shared, "You have an overall systems page on the screen, and then you can drill down into individual pages as well. There's a total of 25 to 30 individual pages, and SpaceX may have added some more since my flight. With any aircraft or spacecraft, you always iterate because it makes sense and it's easy and will help the crew. Ideally, astronauts have very little manual involvement since the spacecraft functions almost entirely on its own. And if the automation doesn't take care of a problem, then the ground is your next layer of defense," Hurley explained, referencing SpaceX Ground Control, which can troubleshoot and send commands remotely. Only if both onboard automation and ground support fail would astronauts step in. This also applies to the most critical task, flying the spacecraft. Dragon runs on a full-time autopilot system that requires no input from the crew. Another major point is safety. Although Soyuz is known for its reliability and safety, Crew Dragon has shown itself to be just as effective, if not more so. Since its launch in May 2020, Crew Dragon has carried more astronauts than any other spacecraft over the same period. By mid-2022, it had taken 22 astronauts to space, surpassing China's total of 20 astronauts since its first crewed flight in 2003. SpaceX has completed nearly 20 successful crewed missions to the ISS and beyond, regularly ferrying personnel for NASA, international agencies, and private clients. Meanwhile, Russia's Soyuz, trusted since the 1960s, continues to launch with crews of 3. But since 2020, SpaceX has overtaken Soyuz in total astronauts flown, thanks to its higher capacity and more frequent missions under NASA's Commercial Crew Program and private contracts. This shift underscores SpaceX's increasing leadership in crewed space travel. That gap will certainly widen further in the future, with an expanded seat swap agreement as Soyuz will have fewer missions. In certain emergencies, Dragon can serve as a crucial rescue spacecraft. For instance, on December 15, 2022, the Soyuz MS-22 spacecraft experienced a significant coolant leak while docked at the ISS just before a planned Russian spacewalk. Although the leaking Soyuz did not pose an immediate threat to the station or its crew, its flight worthiness was uncertain. This meant the MS-22 crew no longer had a reliable emergency escape vehicle. To explore alternative lifeboat options, NASA and the Russian space agency Roscosmos assessed available solutions, including reaching out to SpaceX to consider using one of its Dragon capsules as a substitute for Soyuz MS-22. Another example occurred during the Boeing Starliner crew flight test mission last summer. Due to a technical malfunction, the Starliner was deemed unfit to return the crew to Earth. As a result, NASA turned to SpaceX's Crew Dragon to carry out the return. After being stranded in space for 9 months, the astronauts safely returned to Earth aboard Dragon. Beyond being modern and safe, SpaceX's Crew Dragon is also known for its affordability. A seat aboard Dragon is significantly less expensive than one on Soyuz. Thanks to the partially reusable Falcon 9 rocket and Dragon spacecraft, compared to Soyuz's fully expendable system, SpaceX offers a seat at nearly half the cost. A seat on Dragon 2 is priced at $55 million, whereas one on Soyuz costs $89 million. Looking ahead, SpaceX remains committed to significantly reducing the cost of space travel. One of its primary targets is to make access to the massive Starship system, the company's fully reusable next-generation rocket, more affordable than ever, despite its size and capabilities. Elon Musk, SpaceX's CEO, has emphasized the goal of lowering the cost of a Starship launch to under $10 million. This ambitious figure is grounded in the vehicle's reusable architecture, which is designed to slash expenses by eliminating the need to rebuild rockets after every mission. As launch frequency increases and the technology matures, the cost savings are expected to scale, enabling SpaceX to make space travel more routine and financially accessible. Musk envisions a future where traveling to Mars could become an option, not just for the ultra-wealthy, but for anyone from a developed economy who is willing to make a bold life choice. Back in February 2019, he confidently projected that the price of a one-way ticket to Mars could fall below $500,000, and perhaps even under $100,000. Low enough, he noted, that most people in advanced economies could sell their home on Earth and move to Mars if they want. Acknowledging the extreme challenges of Martian life, he added with a touch of humor that for those who decide Mars isn't for them, the return ticket is free. This vision captures SpaceX's broader mission, not just to explore space, but to make humanity multiplanetary, accessible to ordinary people, not just astronauts or billionaires. If that vision becomes reality, Starship could eventually replace all of SpaceX's current operational vehicles, including the Falcon 9 and Falcon Heavy rockets, as well as the Dragon spacecraft. Designed as a fully reusable and versatile system, Starship is intended to handle a wide range of missions, from satellite launches and space station resupply to crewed lunar landings and interplanetary travel. By consolidating its operations under one powerful, cost-effective platform, SpaceX aims to streamline its launch infrastructure, reduce maintenance complexity, and maximize efficiency across all missions. This strategic shift would mark a new era in space transportation, where a single next-generation vehicle serves as the backbone of everything SpaceX does, from Earth's orbit to Mars and beyond. So, how about you? Are you excited about that future? Let me know in the comments. Starship is SpaceX's next-generation spacecraft, designed to carry humans and cargo to the Moon, Mars, and beyond. It's a fully reusable launch system made up of 2 stages. The upper stage, also called Starship, which travels through space and returns to Earth, and the Super Heavy booster, which provides the power needed to lift Starship off the ground. What sets Starship apart is its massive payload capacity to excess 200 tons in the 3rd generation, its stainless steel construction, which handles extreme heat during re-entry, and its full reusability, which aims to significantly lower the cost of space travel. While it's still in the testing phase, Starship is built for deep space missions and could revolutionize the future of space exploration. For 2 years, SpaceX has conducted 8 Starship testing flights and is preparing for its 9th test, which is scheduled no earlier than April 2025. Did you know that the woman who inspires me the most is Sally Ride, the first American woman to travel to space? I've always admired how she broke through gender-based barriers in the astronaut selection process, showcasing her technical and professional skills in what was largely a male-dominated field. When she applied to NASA in 1977, women had only recently been allowed to become astronauts. Prior to that, NASA required candidates to be military test pilots, a role that was not open to women at the time. In fact, during congressional hearings, well-known astronauts like John Glenn and Scott Carpenter argued that women shouldn't be sent to space due to their lack of military flight experience. But Sally Ride proved them wrong. With a physics degree from Stanford and years of rigorous training, she flew aboard the Challenger shuttle on June 18, 1983, and operated the robotic arm to deploy and retrieve satellites, clearly demonstrating her technical prowess. Later, she played an integral role in NASA's investigations of the Challenger and Columbia disasters, and became a passionate advocate for inspiring young women to pursue careers in science and space exploration. Her journey opened the door for future generations of women in space. Today, private companies like Jeff Bezos's Blue Origin are trying to carry that torch further. One example is the recent New Shepard mission, NS-31, which featured an all-female crew. However, instead of being celebrated as a landmark moment for young women, the mission was met with criticism, being described by some as end-time stuff and beyond parody.
I'm going to tell you something right now. You are officially an astronaut.
Thank you so much.
How do you feel?
I feel super connected to love. So connected to love. I think this experience has shown me you never know how much love is inside of you.
The crew included celebrities like Katy Perry, Gayle King, and Jeff Bezos's fiancée, Lauren Sanchez. Dressed in spacesuits for a brief 11-minute flight, they made headlines as the first all-female crew to reach space. But compared to what NASA veterans like Sally Ride had to endure, the path seems remarkably smoother for today's space travelers. So, what makes someone an astronaut? According to the FAA, commercial launch crew members had to both meet specific requirements for flight crew qualifications and training, and fly above a 50-mile, 80-kilometer altitude on an FAA-licensed or permitted vehicle. But on July 20, 2021, the same day that Blue Origin launched its crewed suborbital mission, using the New Shepard vehicle, the federal agency added new criteria to its short list of qualifications. With the new change, those who fly on commercial space missions must also have demonstrated activities during flight that were essential to public safety or contributed to human spaceflight safety. That rules out most space tourists. Now about NS-31. NS-31 was a short suborbital hop, about 11 minutes, including just a few minutes in microgravity. While it marked the first all-female crew for Blue Origin, it wasn't a scientific mission or part of any long-term exploration goal. The participants didn't train like traditional astronauts, operate the spacecraft, or perform mission-critical tasks. They were mostly public figures and celebrities. So, were they astronauts? It sounds like you get into an airplane and someone calls you astronauts, pilots, or something like that. Perhaps the only basis that Blue Origin relies on is that its customers went above the Kármán line, 100 kilometers, the international boundary of space. So by some definitions, yes, they went to space. But culturally and professionally, many argue that they were space tourists, not astronauts. For short, the title of astronaut carries weight, training, service, science, and risk. Blue Origin's NS-31 passengers don't match those traditional expectations. While they may hold the bragging rights of having gone to space, calling them astronauts can understandably feel like a stretch to many professionals and the public. In contrast to Blue Origin's crew, the crew members on missions like SpaceX's Crew Dragon's Fram-2 and Polaris Dawn can definitely be considered real astronauts by both modern and traditional standards. First and foremost, these missions are usually long-duration flights to orbit, not suborbital joyrides. Therefore, they involve intensive astronaut training, often in collaboration with NASA. For example, the Polaris Dawn crew engaged in over 2 years of rigorous training starting from May 2022, including centrifuge operations, hundreds of hours of SpaceX Dragon capsule simulations, skydiving, survival training, high-performance aircraft piloting, zero-gravity flight training, altitude training, classroom academics, and medical testing. They received extensive extravehicular activity, EVA training, both underwater and suspended operations, along with associated medical training, preparing them for the mission's historic commercial spacewalk. The crew also trained in fighter jets through Draken International, diving and skydiving with the U.S. Air Force Academy, and spent time in decompression chambers at NASA's Johnson Space Center. The training was described as more intense than anything experienced by some crew members, emphasizing teamwork development and adapting to new EVA suit designs developed by SpaceX for this mission. Notably, 2 of the Polaris Dawn crew members, Sarah Gillis and Anna Menon, have direct NASA experience, with Menon having worked as a biomedical flight controller for the International Space Station, and Gillis responsible for training NASA astronauts for SpaceX missions. These are things that are hard to find in the preparation phase for fun journeys aboard Blue Origin's New Shepard spacecraft. The Fram-2 crew training is not exceptional as well. The Fram-2 crew underwent over 8 months of training, including numerous simulations and emergency preparedness exercises, in preparation for their mission to orbit Earth's poles, a flight path never before flown by humans. Their training included rehearsals of launch day activities and mission simulations, ensuring readiness for the unique challenges of polar orbit and the scientific experiments planned. While Fram-2's training details are less elaborated than Polaris Dawn's, the mission involved collaboration with SpaceX and likely incorporated NASA protocols, especially given the scientific nature of the experiments and the use of NASA facilities like Kennedy Space Center for launch. The Fram-2 crew includes experienced explorers with backgrounds in polar expeditions, and their training focused on conducting 22 scientific experiments related to human health and space environment research, which aligns with NASA's research interests. In addition, private missions such as Fram-2 or Polaris Dawn have also made significant contributions to human spaceflight, aligning with the FAA's requirement of activities during flight that were essential to human and public safety in spaceflight. The high-risk, experimental Polaris mission featured the first commercial spacewalk, testing SpaceX's newly designed EVA suits. These suits underwent extensive development and testing, including hyperbaric chamber trials and simulations, to ensure astronauts' safety despite lacking a traditional primary life support system backpack. The mission developed new operational procedures and contingency plans to mitigate risks such as micrometeorite impacts and exposure to the sun, enhancing EVA safety protocols for future commercial and governmental missions. The crew passed through parts of the Van Allen radiation belts, exposing them to radiation doses equivalent to about 20 years of Earth-based exposure within a few hours. This provided critical data on the health effects of space radiation on humans, informing safety measures and shielding requirements for future long-duration missions beyond low Earth orbit, including lunar and Mars exploration. Throughout the mission, the crew conducted nearly 40 scientific experiments focused on human physiology and microgravity, including advanced medical monitoring. These studies contribute to understanding how spaceflight affects the human body, improving medical protocols and emergency preparedness for astronauts, which directly enhances crew safety. SpaceX and the Polaris Dawn team implemented rigorous safety drills and contingency responses for all mission phases, including launch, orbit, EVA, and re-entry. The mission emphasized communication, transparency, and iterative safety reviews, reflecting a high standard of risk management that benefits the broader commercial spaceflight industry and public confidence in space travel safety. Last but not least, by pushing the altitude record for crewed spacecraft to 870 miles and successfully returning the crew safely, Polaris Dawn demonstrated the viability of higher-risk missions with robust safety measures. This sets a precedent for future commercial and scientific missions, expanding human spaceflight capabilities while maintaining safety. Meanwhile, the FRAM-2 mission contributed to human and public safety, primarily through its scientific research and operational achievements in a novel polar orbit. FRAM-2 was the first human spaceflight mission to enter a polar orbit, flying over both the North and South Poles. This expanded the understanding of spacecraft operations and human factors in a unique orbital environment, which is important for future missions that may require diverse orbital paths for Earth observation or deep space transit safety. The crew conducted 22 scientific experiments focused on human health and microgravity, including monitoring hormone levels using urine strips, sleep quality tracking with wellness rings, and studying space-induced motion sickness. These studies provide valuable data on how humans respond to spaceflight conditions, improving medical protocols and safety measures for astronauts on long-duration missions. The mission included photographing auroras and studying Earth's polar regions from orbit, contributing to environmental and space weather knowledge that can impact satellite operations and public safety on Earth. FRAM-2 demonstrated the capability of safely launching, operating, and returning a crewed spacecraft in a challenging polar orbit, which requires more fuel and precise navigation. The successful splashdown off the California coast marked SpaceX's first West Coast recovery, showcasing operational flexibility and enhancing public confidence in commercial spaceflight safety. After splashdown, there was a test to assess the ability of astronauts to exit the Dragon capsule without assistance. This was a key objective of the mission, aiming to understand how astronauts might egress spacecraft on future missions, including those to the Moon and beyond, where on-site recovery teams might not be immediately available. Not only does it have scientific significance, but FRAM-2 also has educational significance for the public. Through the onboard amateur radio system and the FRAM-2 ham competition, the mission engaged students and the public in space science, fostering awareness and interest in space safety and exploration. In summary, unlike the NS-31's crew, both FRAM-2 and Polaris Dawn crews train like astronauts, work like astronauts, and face risk like astronauts. So yes, they've earned the title. So what's your take? Do you share the same thought with me? Let me know in the comments. The NS-31 mission marks the 11th human spaceflight for the New Shepard program. The astronaut crew included Aisha Bowe, Amanda Nguyen, Gail King, Katy Perry, Carrie Ann Flynn, and Lauren Sanchez, who brought the mission together. Including the April 14th mission's crew, New Shepard has now flown 58 people to space, including 4 people who have flown twice. On April 10th, a photo surfaced online showing Starship 36 inside Megabay 2 at Starbase, getting ready for its 10th test flight. But what really grabbed attention was the ship's thermal protection system, TPS. It had a patchwork look that suggests SpaceX might be testing new materials or techniques, possibly inspired by or based on TUFROC. Back in 2019, SpaceX teamed up with NASA to license and further develop a technology called TUFROC, short for Toughened Unipiece Fibrous Reinforced Oxidation-Resistant Composite. It's a reusable heat shield material originally developed at NASA's Ames Research Center. Built to handle the extreme heat of re-entry, it's a perfect match for Starship's mission to be rapidly reusable. As part of the agreement, NASA shared technical insights with SpaceX, including documents, test data, and even weekly calls with experts. The goal was to help SpaceX improve its TPS, especially for areas like the nose and wing edges that get hit hardest during re-entry. TUFROC stands out for being both heat-resistant and lightweight, ideal for a spacecraft aiming to fly again and again on missions to low Earth orbit, the Moon, and eventually Mars. It's clear SpaceX is taking a page from NASA's playbook, especially the Space Shuttle program, while building its own next-gen TPS. When you compare Starship's TPS to that of the shuttle, the evolution becomes obvious. Looking closely at Starship's tile design, you'll notice similarities to AETB Advanced Environmental Barrier tiles, which were used during the final years of the Space Shuttle. These tiles have a TUFI, toughened unipiece, fibrous insulation, coating and molybdenum disilicide, just like what seems to be present on Starship. In fact, when Elon Musk talked about the tiles, he mentioned they're made from silicon and aluminum oxide. He also revealed that the newest batch, used starting with Starship's 5th flight, are twice as strong as before. This improvement might come from using thicker alumina fibers, making them tougher even if it adds a bit of weight. The shuttle used tiles with an outer coating made of tetrasilicide and borosilicate glass. Starship tiles share that shiny black look, and during re-entry, you can spot a brilliant blue plasma glow around the vehicle. That's a sign of borosilicate, which burns blue and is known for its low thermal expansion, making it resistant to cracking under extreme heat changes. The shuttle was a marvel of its time, but its TPS had major limitations by today's standards. Its shape was so complex that every one of its 24,000 heat shield tiles had to be custom-made. They varied in size and thickness, which made repairs and replacements slow and expensive. The shuttle didn't use one material for everything. It relied on a mix. Reinforced carbon-carbon, RCC, on the nose and wing edges, Li 900 silica tiles, HRSI on the belly, and felt reusable surface insulation, FRSI, in cooler areas. While clever, it created a logistical headache. In contrast, Starship is designed with simplicity in mind. Its panels are mostly uniform in size and shape, with only about 100 custom pieces for tricky spots like the nose. SpaceX adopted a tile-based approach for Starship, but aimed to address the shuttle's shortcomings. Starship's TPS uses hexagonal ceramic tiles, which are more uniform in shape and designed to minimize gaps. Unlike the shuttle, where tiles were custom-shaped for different parts of the orbiter, Starship's standardized hex tiles simplify manufacturing and installation. Elon Musk has emphasized that these tiles are designed to avoid the need for gap fillers, like the Nomex felt used on the shuttle, which required labor-intensive inspections. Starship's TPS eliminates the lengthy visual inspections that the shuttle needed, around 80,000 labor hours per flight for TPS maintenance alone. This approach streamlines production, allows for automated manufacturing, slashes costs, and improves reliability. This simplicity could also be a lifesaver on Mars missions. If a tile breaks, astronauts could carry spares and quickly swap them out. That kind of repairability could make the difference between a safe return and a mission failure. It's a perfect example of how modern aerospace engineering favors smart simplicity, less complexity, more efficiency. The shuttle's tiles were made from high-purity silica, which offered great thermal protection but were fragile. They cracked easily and needed to be re-waterproofed before each flight to avoid water absorption during launch, which could freeze and cause damage in space. The reinforced carbon-carbon, RCC, on the wing edges was stronger but still vulnerable, as seen in the Columbia disaster in 2003, where a piece of foam struck the RCC during launch and led to the orbiter's loss during re-entry. SpaceX, learning from that, has aimed to make Starship's TPS more resilient. While the full makeup of its tiles isn't publicly known, they're likely made from a ceramic matrix composite, CMC, or a similar advanced material. possibly influenced by NASA's TUFROC. SpaceX licensed TUFROC in 2019, a material known for being tougher and more reusable than the shuttle's silica tiles. It was even used successfully on the X-37B. On top of that, SpaceX chose stainless steel as Starship's base structure. It can withstand more heat than the shuttle's aluminum body, reducing the stress on the tiles. This hybrid design, mixing metal and ceramic, means Starship can take minor tile damage and still survive re-entry, unlike the shuttle. The shuttle mainly relied on passive cooling, where materials absorbed and radiated heat. NASA did look into active cooling systems like transpiration cooling, where a fluid seeps out to absorb heat, but it was never used due to cost and complexity. SpaceX, however, has integrated active cooling into Starship's design. It uses methane, possibly in a transpiration or regenerative cooling system, on the windward side, where heat is most intense during re-entry. Methane can seep out and evaporate, carrying away heat, or circulate through pipes to manage temperature. This significantly reduces the heat stress on tiles and lowers the risk of cracking. While the shuttle didn't use active cooling, NASA's past research laid the groundwork for what SpaceX is doing now, especially as Starship faces hotter re-entries from places like Mars. The shuttle was built to be reusable, but its TPS became a huge bottleneck. Inspecting and replacing individual tiles took time and money, and each one had to be re-waterproofed and recertified for flight. This turned what was supposed to be a quick turnaround into months-long delays, cutting into cost-effectiveness. SpaceX built Starship's TPS from the ground up with fast reuse in mind. Its hexagonal tiles are attached using a pin system, no glue, so they can be swapped out quickly. The shuttle's tiles, on the other hand, were glued on with a strain isolation pad, SIP, making them difficult and time-consuming to remove. Starship also avoids using gap fillers by minimizing gaps between tiles, which means fewer things to inspect or fix. And if some tiles do come off, Starship's stainless steel frame can handle up to 1,400 degrees Celsius, enough to survive re-entry, something the shuttle's aluminum couldn't do. Way back in the Apollo days, NASA used ablative heat shields that burned away to carry off heat. The shuttle ditched that for reusability, but it came with all the TPS maintenance headaches. Even so, NASA's work on ablative materials provided loads of useful data for future spacecraft. While Starship's main TPS is reusable, SpaceX has considered using ablative coatings as a backup or for early Mars missions, where getting the ship back in one piece might not be a top priority. These ablative shields can handle the intense heat of suborbital re-entries, while freeing up room for more cargo by skipping some of the heavy active cooling systems. It's a smart balance, taking lessons from the shuttle-era struggles and applying them to real-world mission needs. Another important change is how the tiles are attached. The shuttle used adhesive to stick them on, which, combined with its aluminum structure, couldn't handle extreme heat, so the tiles had to be thick and heavy, adding to the vehicle's mass. Starship does it differently. Tiles are mounted with smooth pins that lock them into the steel body. It's so secure that, under normal conditions, you can't remove a tile without breaking it. An approach that's rugged, efficient, and built for the long haul. One of Starship's most important innovations is its positioning. Unlike the Space Shuttle, which was mounted beside its booster, Starship sits on top of the Super Heavy booster. This layout isn't just visually different, it's safer and more efficient. Mounting Starship on top shields it from intense vibrations and reduces the risk of damage to its thermal protection system during launch. Starship's overall design also gives it a big edge when it comes to surviving the brutal heat of re-entry. Its chunky, cylindrical shape isn't just iconic, it's intentional. That blunt form helps spread out heat and protect the spacecraft as it barrels back through the atmosphere at hypersonic speeds. The flat front creates a compression zone where heat builds up rapidly, but it also forms a temperature gradient that cools off further down the ship. This natural buffer acts as an aerodynamic heat shield, offering better thermal protection than the shuttle's sleeker winged shape. When it comes to SpaceX's success principles, it's impossible not to mention the iterative approach, and the company has applied it in the process of refining and testing the thermal protection system. During Flight 4, viewers saw heat shield tiles falling off, dubbed the shooting stars. But SpaceX didn't just brush it off. They responded by improving the design for Flight 5. One major change? They added a layer of ablative material under the tiles. So if any shields fall off, the exposed steel has a backup layer protecting it from temperatures that can hit thousands of degrees. SpaceX also learned from the heat damage seen on the control surfaces during Flight 4. These wing edges are especially vulnerable to thermal loads. But Starship's wings are designed to fold inward and can be rotated to the leeward side, minimizing their exposure to direct heat. Just like NASA before it, SpaceX has taken testing seriously. They use arc jet testing, similar to NASA's methods, to simulate re-entry heat and pressure. Every test flight offers new data, helping to refine the TPS even further. That patchwork look on Starship 36's heat shield? It might be SpaceX experimenting with new materials and techniques, just like NASA did over 3 decades of the shuttle program. But SpaceX's pace is faster. Their rapid prototyping and frequent flights let them improve Starship much quicker than NASA ever could with the shuttle's slower launch schedule.